Hey, my name is Lissington and my project is called the Dynamic Garden Watering System. I've looked at the problems that are generally faced in New Zealand, and poor management of water seems to be a big issue. The sustainability of water in New Zealand is far from impeccable, as over-irrigation of household gardens and crops take up a sizable proportion of the country's water supply. A large proportion of this misuse is due to households, specifically when watering gardens. I have developed a system which conserves the precious resource of water by limiting and automating the time that garden hoses are turned on, based on the current environmental conditions. The system has undergone many testing stages, starting off as a garden data logger, which measured the soil humidity, air temperature, and air humidity over a period of 7 days. This information I gained proved useful for me, as I was able to determine relationships between different variables within the garden, allowing me to retain the most comfortable soil humidity for any plant. The system consists of an Arduino microcontroller, a soil moisture sensor, a DHT22 air temperature and humidity sensor, a solenoid water valve, and a waterproof enclosure. My system is easily implemented as it is placed in series with any existing hose or sprinkler setup. Conventional automated sprinkler systems do not limit the water based on the environmental conditions. They simply base their water on what time of day it is. This is wasteful, as often there is sufficient soil moisture levels at these times. The systems are supplying more than is necessary. My system tends for the health of the soil more directly. If the soil is too dry, it will output a comfortable amount of water based on how dry the weather is. These conventional systems cost upwards of $150. The parts cost for my system is only $23, a price which any household can afford. The software of my system has changed throughout time, becoming more efficient with each revision. The benefits of using an Arduino as a controller is it's programmable. I can continue to release updates for the board, or configure the settings to allow for situational circumstances, such as by limiting the water output even further for districts with stricter water constraints. The implementation of my system throughout households would result in greater water conservation, leaving a larger volume of water in New Zealand's reservoirs, so councils will be less obliged to enforce water restrictions. In the future, I wish to design my own circuit boards for the systems, so that the cost of each unit is decreased due to the hardware being more specialised for its use case. I also wish to add Wi-Fi connectivity to my system, so that water restrictions applied from councils can be viewed and applied to the households in the district, so that the water restrictions which are applied affect the usage of water more directly, instead of the reliance in the household to turn the hose on and off and regulate water usage. This system could potentially be extended to an agricultural setting, so that water outputs of a greater magnitude can become regulated by the same proportion, as agricultural settings take up a very large percentage of New Zealand's water output. I have also developed another system which controls the water output of sprayers on the grain transport hoppers. These hoppers are used at shipping docks to transport the grain from the ships to the transport trucks. Conventional misting systems will leave the water output on until all of the grain has been removed from the ship, a process that could take hours. The system I developed utilises an Arduino microcontroller to control the output of water based on when the crane's bucket is over the hopper, plus an extra 4 minutes for the dust to settle. This reduces air pollution as well as water usage. This increases efficiency of water usage at ports, in turn making water a more sustainable resource in New Zealand. The system consists of an ultrasonic distance sensor to detect the crane's bucket, uses relays to control the pump, solenoid water valve to control the water output, an indicator light, Arduino Pro Mini as a controller, and is housed in a waterproof enclosure. The usual 2 hours of water usage for the sprayers has been reduced to approximately 40 minutes, using around a third as much water. If every port in New Zealand implemented this system, then a considerable amount of water would be conserved, compared to the current inefficient systems in place.